DSPy's data preparation pipeline leverages modular dataset loading and example construction to streamline the integration of external datasets into program-ready training instances. The framework's DataLoader abstraction facilitates seamless ingestion from Hugging Face repositories, while the example class enables structured augmentation of raw data with program-specific fields like hints and labels. We will now examine how the Banking 77 dataset is loaded and transformed into a shuffled collection of 2,000 training examples, each enriched with class name hints derived from the original labels. This setup pattern demonstrates DSPy's approach to preparing datasets for subsequent optimization workflows, where these examples will serve as the foundation for prompt tuning or fine-tuning operations.
Import random. From typing, import literal. From datasets, import load dataset. Import DSPy. From DSPy, datasets, import DataLoader. Hash load the Banking 77 dataset. Class is equals load dataset. Poly AI / Banking 77. Split equals train. Trust remote code equals true. Features label. Names. Quargs equals fields. Text label input keys. Text split. Train trust remote code. True. Hash load the first 2,000 examples from the dataset and assign a hint to each asterisk training example. Train set equals. DSPy examplex hint equals classes X. Label. Label equals classes X. Label with inputs text. Hint. For X in DataLoader. From Hugging Face dataset name equals Poly AI / Banking 77. Asterisk Quargs 2000. Random. Random 0. Shuffle train set.
This code demonstrates how to load and prepare a dataset for DSPy programs using the DataLoader and example classes. The pattern focuses on transforming raw dataset entries into structured examples that can be used for training DSPy modules. The DataLoader class is used to fetch the Banking 77 dataset from Hugging Face, specifying the required fields, text, and label and input keys. The dataset is then processed into a list of DSPy example objects, where each example includes the original text, a hint derived from the label using the class names, and the label itself. The withInputs method is called to specify which fields should be treated as inputs to the DSPy module. This preparation ensures that the dataset is formatted correctly for training, with hints provided to guide the model during the training phase. The approach of adding hints to training examples is particularly useful for classification tasks, as it provides additional context to the model. The shuffling of the dataset ensures that the training process is not biased by the original order of the data. This pattern is efficient for preparing datasets in DSPy, as it leverages the framework's built-in utilities to handle data loading and transformation, making it easier to integrate with DSPy's optimization and training pipelines. Let's break it down.
Import random.
Imports Python's built-in random module for generating pseudo-random numbers and performing random operations like shuffling sequences or selecting random elements.
From typing, import literal.
Imports literal from the typing module, which enables type hints for variables that can only take specific literal values.
From datasets, import load dataset.
Imports the load dataset function from the Hugging Face datasets library, which provides utilities for loading and working with datasets in machine learning workflows.
Import DSPy.
Imports the DSPy library, making its classes and functions available for use in the current Python script.
From DSPy, datasets import DataLoader.
Imports the DataLoader class from the DSPy datasets module, which provides functionality for loading and managing datasets in DSPy.
Class is equals load dataset. Poly AI / banking 77, split equals train, trust remote code equals true, features label, names.
Loads the Poly AI Banking 77 datasets training split with remote code execution enabled, then extracts the class names from the label feature and assigns them to the variable classes.
Quargs equals fields, text label input keys, text split, train trust remote code, true.
Creates a dictionary, quargs, with configuration parameters for dataset loading, specifying that the dataset should include text and label fields, use text as the input key, load the train split, and allow execution of remote code.
Train set equals.
Initializes a list variable named trainset as an empty list. This creates a mutable sequence container that will likely be populated with training data examples later in the code, though the specific contents aren't visible in this segment. The square brackets denote an empty list literal in Python.
DSPy examplex hint equals classes x, label equals classes x, label with inputs text. Hint.
Creates a DSPy example instance with 3 fields. The input x, a hint set to the value from class's dictionary using xLabel as key, and a label also set to the same class as x, label value. The withInputs method specifies that text and hint are the input fields for this example, effectively marking them as the features that would be provided during prediction, while the label would be the target.
For x in DataLoader, from Hugging Face dataset name equals Poly AI / banking 77, asterisk quargs 2000.
Iterates over the first 2,000 examples from the Poly AI Banking 77 Hugging Face dataset using a DataLoader instance. The loop variable x receives each example sequentially, with any additional DataLoader configuration passed via quargs. This loads a subset of the banking domain intent classification dataset for processing.
Random 0, shuffle train set.
Creates a random number generator instance with a fixed seed value of 0, then uses it to shuffle the elements of the train set list in place. The fixed seed ensures reproducible shuffling across different runs. DSPy's data preparation pipeline transforms raw datasets into structured training examples through modular loading and augmentation. The DataLoader abstraction handles seamless ingestion from Hugging Face, while the example class enriches each entry with program-specific fields. In this Banking 77 example, the pipeline loads 2,000 training instances, augments them with class name hints derived from labels, and shuffles the dataset for unbiased training. The withInputs method explicitly marks text and hint as model inputs, while labels serve as targets. This pattern of hint augmentation is particularly valuable for classification tasks, providing additional context during training. The fixed random seed ensures reproducibility, making this approach both efficient and reliable for preparing datasets in DSPy's optimization workflows.
The DataLoader shuffles 2,000 truths. Yet the first example clings to its hint like a barnacle to a ship that never sails.